Okay, so in this video, we will look at two expressions involving logarithms, and our objective in each case will be to simplify the expression using the fundamental properties of logarithms. So let's start with the logarithm base 2 of 96. So in this case we have a logarithm with the base being 2. So we're going to try and see if we can factor from 96 an exponential function base 2, so it can cancel with the corresponding log. So if we factor 96, we can factor it underneath it. So 96 is divisible by 3. So this is, well, if you think about this, 3 times 2 is 6. 3 times 30 is 90. So it's 3 times 32. And 32, if you start factoring, as it's an obviously even number, so if you factor 2's from here, you get that 32 is a perfect power of 2. It is 2 to the 5. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. So we'll go with this factorization. So we have the log base 2 of 3 times 2 to the 5. But we can't just cancel the log with the exponential function base 2. I mean, sure, the bases match, but there's this annoying multiple of 3 up front. So it seems that we're stuck with it. But before we cancel the log base 2 with the exponential function base 2, we can use another property of logarithm, right? Which is the log of a product is the sum of the individual logarithms. So we have the log of a times b. We know this is the log of a plus the log of b. The log of a product is the sum of the individual logarithms. And now we can cancel the log base 2 with the exponential function base 2. Here we can't do anything about this. The bases don't match. But in the second case we're left with quite simply 5. So in the end we're left with the log base 2 of 3 plus 5, which is a nice simplification from the original expression, log base 2 of 96. This is much simpler. Let's look now at one other example. Taking, say, the log base 8 of 27 divided by the log base 5 of 64. And what's interesting here, even though the bases don't match, 27 is 3 cubed, and 64 is 4 cubed, right? 3 times 3, 9 times 3, 27. 4 times 4, 16 times 4, 64. You might wonder, well, why is this interesting? Well, let's see. We're going to use the property of logarithms, right? The bases in either case do not match, but we know that if we take the log of an exponent, we can pull the exponent up front as a constant multiple of the log. So this will become 3 times the log base 8 of 3 over 3 times the log base 5 of 4. So we can cancel both 3's, and we're left with a simpler quotient. Still a quotient of logarithms, but the arguments are much smaller. So we have the log base 8 of 3 divided by the log base 5 of 4. And this is the best that we can do. And that's it.